Good morning, class. So today we would discuss about certain types of maintenance and concepts like maintenance scheduling, equipment reliability. So everything is going as per the syllabus. So I would share the syllabus with you, which is accessible on internet as well. So you can have a run through as to what all have we covered. Okay, so you will find these concepts there. There's nothing extra here. So we would discuss about different types of maintenance in this class. So let's proceed. There are 5 types of maintenance. Okay, we have got corrective maintenance, planned maintenance, predictive maintenance, preventive maintenance, routine maintenance. Okay, most of them we have come across in real life as well, or we have heard of it, but how exactly does it fall in place in a factory, or what is the thing which differentiates each type of maintenance is something which you should clearly know. So you can expect these questions for 2 marks any one type of maintenance, but maybe for section B or something they can ask you for all 5 types. All right, so let's discuss in detail about each one. The first one is corrective maintenance or breakdown maintenance. This happens, we learned about corrective action and preventive action, right? Someone who takes a manager who takes action only after the breakdown, we can call that action as a corrective action. The one which is done before there is any technical issue or before any breakdown, you take a, what do I say, you anticipate that there's going to be a breakdown, you take steps prior to it. We call it as preventive maintenance. So here corrective maintenance is where you find out that there is some technical issue with the machines or the equipment. There is a breakdown, which means the work stops, the machine stops working. All right, so how can you bring that machine to the original form? How can you set that broken down machine back into the original form? All your repair shops, the different sort of repairs, everything is related to corrective maintenance. Okay, so corrective maintenance happens when there's a work stoppage because of the machine breakdown. All right, and this is the general term, another term for all your repair work. So repair is done only after there is a breakdown of the machinery or breakdown of the system. We try to repair it. Okay, so repair happens only when there's a breakdown. So same as a thing, you can call this as breakdown maintenance, which is also called as operate to failure maintenance, firefighting maintenance, or unplanned maintenance. You never know when is that breakdown going to happen, so you have to have a special regard for this. Now what is the main objective of breakdown maintenance? This is there only for corrective maintenance because this is your normal case of breakdown. So we have to find out what are the different ways we have to look forward when it comes to corrective maintenance. So first you have to get the equipment back in operation. The one which has stopped should be brought to the normal condition and it should start operating. Now uh, suppose we have to call in some repair team. We have to pay them their fees or their charges. So we have to find different methods to control the cost. Maybe one repairs team which you may be outsourcing from outside, say repair crew or repair team A, they can do the work at lesser expenses than the second repair group. So we have to choose, we have to see the cost factor also, cost of repairs, and then make a decision. All right, and suppose the work is stopped and it is restarted. People, for example, see, normal production is supposed to happen in 8 hours. So for 4 hours, there's a technical breakdown. For 4 hours, no work can happen because the machine has broken down. But that does not mean, suppose the organization needs to urgently give an order. What does it do? Even after those 4 hours, they ask their employees to stay back and they give and make them work overtime. So we pay them overtime charges. So that cost also has to be controlled. Control the cost of operation of repair shops. You might have different repair shops within the facility of your factory, which is needed because you can expect a breakdown sometime. And if you totally depend on the external repair shops, it's not mandatory that they stay open all the time, even when they need it, when we need it. So what you can do is you can have minute repair shops within the factory premises, but you should also see that the cost of operating such repair shops, okay, is less. Everything involves a cost. Everything comes with a price. We have to check whether running a repair shop within the factory, whether it's profitable, whether it is reducing the some type of cost. All that has to be ascertained. Only then go for the step. Control the investment in replacement spare parts which are used when machines are repaired. So we might have to keep some spare parts, which is, you know, the spanners or anything of that sort, which has to be kept there. For especially for machines which are joined by a lot of nuts and bolt, you'll have to keep a inventory which includes you know, 5 to 6 sets of nuts or bolt, which means to say if the machine breaks down, you can take some of the spare parts and try to fix it in. Okay, but again, you should not invest a lot in getting these spare parts. Okay, you have to plan your investment likewise. You should not overstock it, you should not understock it. Is it clear to you? All right. Then preventive maintenance. Preventive maintenance, we take this maintenance before the actual issue happens. We see to it that we come out with different, you know, different concepts or different things which we do so that we can anticipate or we can counter a future problem. Okay, so before the thing happens, before the breakdown happens, we take steps to ensure that everything is proper. In what all ways can you do it? First is proper design and installation of equipment. Whether your equipment is of the required design, whether it is facilitated in that particular place, whether it is installed properly. There are some machines which cannot be closer to the you know, to the fire or to any heat, uh, any areas which, you know, has a lot of heat or something, maybe you cannot place it there. So based on those specifications of the machinery, you should place it in a proper manner. There are some things, right, which even when you shop for few you know, items which help you in making food, the ingredients, some of them have to be stored in a cool, dry place. So all the specifications are set even for machines, so that has to be used up. There should be a lot of inspection of plant and equipment. Okay, don't expect the work to go continuously. You need to have an inspection team who will walk around the plant or the equipment and see whether there are any issues with it. Repetitive servicing. So we give our cars, our vehicles for servicing, so that, you know, in the future, sometime when we are driving, there's no brake failure, nothing of that sort. Everything is given a proper servicing time. We give it for servicing maybe every quarter or every 6 months, I'm not sure. So you can give all this, ensure that proper servicing happens. Okay, this is one type of preventive thing. Adequate lubrication, cleaning and painting of building and equipment. So if you want your equipment to work, especially the ones which have, you know, huge wheels and all that, they tend to friction. You have seen the wheels, no? One moves here, one moves here. We have learned it in physics, if I'm not wrong, or we have simply seen it where one, especially in your clock, old time clock also, when your one wheel turns, the next wheel which is kept next to it, in what direction will it turn and all that. So when this is the general concept of machine, we learn it in under machine learning for engineering. So when this is the thing, we have to check that there is no friction between the wheels, that it doesn't get stuck somewhere. So what do? You apply some grease or you apply some oil, so that, like a lubricant, which allows everything to move without friction. So these are the steps which you can take under preventive maintenance. I hope my example was clear. If not, reach out to me. Okay. Predictive maintenance are certain sort of sensory or sensitive instruments which you place to detect the error. Suppose you go to a building and you use the lift. So there is this capacity of the lift which is given. Like suppose sometimes they give it in the form of weight, total weight, or they say not more than 6% to 8%. Okay, suppose there's overloading, that is, a lot of people get inside the lift beyond the limit, then the lift would give signals and it would not move, right? So this is the main concept of predictive maintenance, and especially when you travel by car, if one door is not closed, there are cars which give sensory information saying that one of the doors is not closed. That is why you check all the doors, you open the doors and close it properly and see where exactly did the lock fall in place. So these are the sensitive instruments which help you in detecting what is a warning signal, whether it has gone beyond the capacity or not. So suppose a machine can only, say, in 1 minute process 5 kgs of some product. You exceed the limit, it shows a warning signal, like how is shown in the picture. You'll have a screen which says warning, capacity load has been exceeded, something like that. So this is where you use certain instruments to predict what is the load capacity, whether it has gone beyond. Suppose you feed a lot of material, then it leads to a breakdown. So instead of that, once it crosses the load capacity, it gives out a proper signal. This is your predictive maintenance. I hope it is very clear to you. Okay. Routine maintenance is a maintenance which you do periodically. Okay, it is required that you do this maintenance periodically. There are two ways of doing it. First, running maintenance. Second, shutdown maintenance. So running maintenance happens when you do the maintenance work when the machine is running, when it's operating currently. Okay, you can put some oil, or you can do some sort of cleaning when the machine is still working. Shutdown is where, in order to do the maintenance work, you would have to close it down. So maybe after the workers leave, you can close down the machine and you can do the maintenance properly. Next day when the workers come, they will have no technical issues. So that is there. So we see this shutdown maintenance normally for certain websites or certain links where they say website is under construction or website is under maintenance. So they've closed down the website and they are doing the maintenance work there. This is something which we come across, once or twice. So routine maintenance is, repeated checking, repeated inspection. You don't stop at it. It's more of a schedule, like a planned maintenance sort of thing. But this can be done in running maintenance, that is when the machine is operating, and shutdown maintenance when you have to close down the machine to do the work. Now, what is plant maintenance? Very similar to your routine maintenance. So if you go to the college washroom or any other washroom nowadays, you find a chart, okay, which says this week which attender is supposed to clean the washroom, what all has to be checked, whether you have to place the liquid in the what do I say, in the soap dispenser, whether the tissue is kept, whether the dustbin has been emptied out. So there are different columns. So the person who does all that work would have to give a check on this. You might have come across this sheet, right? So here everything happens as per a plan. Okay, this is very similar to routine maintenance, all right, but here a lot of focus is given on the maintenance plan. Maybe some 7 to 8 set of people are doing this job. So the job is divided among those 8 people. Who does what, which day, which week? This is your main concept of plant maintenance. So routine maintenance happens with periodic checking, periodic thing. It also goes as per the plan, but there we can differentiate between running maintenance and shutdown maintenance. But planning is where you try to come out with a plan as to what maintenance can be done when, by whom, in what way, and all that. Just think about the restroom example, and based on that they undertake the maintenance process. So this is done in a very proper manner. This planned maintenance can also be routine maintenance is one type of plant maintenance, and also we have something called as maintenance scheduling, which is another form of plant maintenance. So here we go as per the plan, with the timing, with the schedule, with who all are doing what work, when. Everything is given in detail in the maintenance plan. I hope it's clear. So like I discussed, what is maintenance scheduling? Maintenance scheduling is a type of plant maintenance wherein during one given period of time, that is maybe a year or 2 months or monthly or weekly or daily, you try to plan what all maintenance is to be done when, and you have to set the timing. So we learned about scheduling in 4th unit, wherein we attach a time factor to each of the process. So here also you set a timing for each of the process. Okay, the way to maintain this is that you have to ensure that you are recording every type of maintenance which is done. In the case of restroom, there's a ready chart, okay, set up by the maintenance team to decide what all has been done in one particular week, and they give a tick against it. So you have a record of it. So this is important because if any time, okay, the audit or the management, internal audit or whoever comes forward and asks you, okay, you have to give me the current status of the maintenance done since past 6 months. So you have the data ready with you. You don't have to go and make new data to, spoil up everything. No, you can depend on the data which is there. You don't have to ask your workers whether you have done the maintenance. No, you can have a ready record and give it to them. I'm going everything in detail so that you don't have a question. Okay, there are different types of schedules which you can use in order to do maintenance work. First is weekly general schedule. So you plan your maintenance work in 1 week. What all can be done, by whom it is done, and in what time it has to be done. Daily schedule is where unlike the previous one which goes as per the week, like the example given on 6th October 2014, 10 to 12 he'll do one work, for 2 to 7, 2 to 5 he'll do another work. So you try to plan out a day for the maintenance stuff. Then Gantt charts are charts which is used to time the different tasks. So suppose there is this production process which has 5 machines. So 5 machines need to have the maintenance work done on it. So what do I do? In a day, the first machine, okay, I would say, okay, I need 1 hour of maintenance. So I say 9 o'clock to 10 o'clock. Then the second one, I say like 11 to 12, 13 to 11 to 12, 1 to 2, 2 to 3, whatever be the thing. So this is the same way like how you plan your weekly schedule, how you plan your daily schedule, but here we give a lot of importance to the entire process. We try to break down each machine. So here we are focusing on the project or on the process that we are working on. If we have 5 machines, this schedule would contain information related to only those 5 machines and not any other process. Weekly and daily can include all the processes which is there in the factory. But Gantt chart is specific to one project or one task. And how do you break into different elements and what is the timing associated? Bar charts would help you in understanding. Any common person can check on a bar chart because it's pictorial and representation. You can find out how much of work is done. So you can shade it. It is very easy to analyze a bar chart. Then PERT and CPM, that is Program Evaluation and Review Technique. I don't know whether you have learned it in QA MD, but yes, these are concepts from quantitative techniques which you will learn about sometime. And then we have critical path method. So here we try to find out in what way can the work be completed very quickly. For example, there are 5 machines. Okay, we have the maintenance staff has 8 hours to do the entire work. So the first machine might take half an hour, second machine might take 2 hours, third one might take 3 hours. Okay, so when a person is fresh in the morning and if he is very much energetic in the morning, so what he can do is he can plan that, okay, third one takes 3 hours to do. Let me do it first, finish it off. Go for second hours. The machine which says that you need to do maintenance for 2 hours. Then go for the least one, half an hour or 15 minutes. Based on that, I can plan out the best way to do something. So critical path method is a concept, and PERT is also a concept which you try to find that what is the shortest way of doing something. Okay, shortest and the best way. So here the maintenance can also make a plan which says what is the best way to do the maintenance process in a day or in a week, or he can find out which one deserves more priority. He can work on this and then plan accordingly. So these are the different techniques. You have to know what does each technique, what is it all about. When they ask list out the techniques, you can write a line about each one of them. All right. Okay. Equipment reliability. So here what it means to say is, it says that any equipment or any plant is expected to do the work to do the actual proper work. That is, they have to perform without any failure from their end under a given set of time, so a given set of conditions and in a given set of time. So we expect or we rely on the machines to perform the task within the given conditions, environmental conditions, and within the given time. So equipment reliability can be defined as the probability of performing without failure a specified function under given conditions for a specific period of time. So like how the word means, we rely on the machine to do its task properly. That's the main concept. You can divide it into two types. We have component reliability, we have system reliability. Component reliability is, suppose there is one machine. There are 5 parts attached to it, 5 components attached to this one particular machine. We need to check the reliability maintenance of that entire system. What do? I take the first component. I see whether this component is reliable, whether this component will do the work properly, okay, will contribute to the work properly. Then I go for the next component, the second component. I check on the reliability. Then I go for the third one, fourth one. So when I measure the reliability separately for each component, we call it as component reliability. Okay, maybe see, out of the 5 components of that machine, one component is not reliable enough, so I'll have to change that component and put another one, so that the overall working will not be affected. You understand why we are focusing on component reliability? Simply, if we check the process of the entire machine, okay, it's not doing the work, fine, but whenever there is some issue with the thing, or whenever we have to do the maintenance work, we have to understand what are the causes which would bring down a breakdown or any technical issue. So if we understand whether all the components used in the machine is of good performance level, whether they can be relied upon, then we can easily understand how to go about with the maintenance work, whether it has to be replaced or not. So you can usually measure this by reliability, CR, failure rates, or mean time between failures. Okay, so difference between the reliability is shown clearly in the mean time between failures, or MTBF. But in general, what you need to know is component reliability is where you try to check whether the component would be able to work, what is the probability of the component to work properly with the best performance with a given set of conditions and the time period. System reliability is where, instead of going for each component separately, you consider the entire machine depending on your requirement. You try to find out whether the machine is capable, the machine as a whole is capable of doing the work within the given time in the given set of conditions. Okay, so we try to measure the probability of the entire machines, whether all the components are interacting properly and whether the machine as a system, as a whole system, is working properly. We call it as system reliability. Yes, okay. Now we have certain modern scientific methods of maintenance. So first one is reliability centered maintenance. What we just discussed, we try to find out whether the machines or the equipment is working to its full capacity. It is ensuring good performance with the given set of conditions. Okay, whether it is effective or efficient enough is what is maintained under reliability centered maintenance. So you just need to know what are these type of maintenance. That's it. No huge questions from this. Six Sigma maintenance is a concept which you use in manufacturing. Six Sigma, anyone who's working with the manufacturing side would more or less know what is Six Sigma. So here what you do is you try to measure different business process. One process, though maybe the machine which takes, okay, it's supposed to take 5 hours to work, one machine. All right, we find out that today the machine is working only for machine has to work more than 5 hours. It has gone up to 7 hours. Okay, so prior to all this, we plan, all right, this machine is supposed to work for 5 hours, but suppose there is a change, okay, in the hour in the time schedule for this machine, it can have an increase of up to 3 hours. Okay, so 5 plus 5 hours plus 3 hours would give you 8 hours. So if the machine also goes beyond 6 hours, 7 hours, or till 8 hours, whatever be the time schedule, if it increases from 5 hours to 8 hours, anywhere in between, we can say that this variation is allowed. If suppose it goes to 9 or 10, we have given a limit of 3 years, but it goes to 9 or 10, that is not proper. So we'll have to do some maintenance work to ensure that this does not happen. So here what you try to do is you try to analyze 6 different standard deviations are involved in Six Sigma. We won't learn about like all 6 of them, but the basic concept is we understand what is the variation or what is the exceeding limit for between the same business process. So you compare one business process and another one, you see how much of variation is allowed, how much of difference is allowed. In my case, the machine can go beyond 5 hours, that is it can go till 8 hours. It can show a difference of 3 hours, so 5 plus 3, 8 hours. But if it goes beyond 8, then it's a cause of worry. Okay, so here you try to find out about different variations in business process. Then enterprise asset management, here you try to focus on different machines which is used, physical assets which is used in a factory, especially your plant, equipment and facilities. We try to find out how well the maintenance work is happening with relation to your plant, equipment or any other facilities in an organization. So here importance is given to the physical assets. We try to find out the data, okay, regarding the maintenance or regarding performing the function. You take a plant or an equipment, you see what is the a proper way the machine is functioning, and then you record it. Okay, you maintain a record of it. Okay, and you share that data among other among the people inside the organization. So you try to understand what is there any cause of worry with any of the physical assets like plant, equipment or facilities. You find out some data, you would have to ensure that the data is reaching other people in the organization. So this is what enterprise asset management is all about. You try to evaluate the physical assets, the working of the physical assets, you collect the data and you send it to other people in the organization. Okay, lean maintenance is where you try to identify in waste management we would be learning about scrap, disposal, surplus, okay, residues and many other things. So here what what it means to say is that we have different waste which is generated in maintenance. All right, so we have to ensure that the waste which is generated, they are classified into 7 different types. We would learn about each type in the next part of this unit. So when you classify the waste into 7 different types and you try to find out ways in reducing or eliminating such waste, we call it as lean maintenance. Then computer aided maintenance. So when you're dealing with a bulk of data regarding the people or the plant, or data regarding people, plant or equipment, you can always use a computer system to help you with the maintenance work. When you're dealing with bulk of data which has to be processed quickly or analyzed quickly, we can use computer systems for the same thing. So when you decide to use computer systems, computer systems for your maintenance, we call them as computer aided maintenance. So reliability is where you check on the performance, whether it would be able to work in a proper operational, effective or efficient manner. Six Sigma is where you try to find out what are the different variations in business process, how well can it vary, whether it can go beyond 3 hours or 4 hours of work, whatever be the thing. Enterprise asset management is only for the maintenance work regarding physical assets, which is your plant, equipment and facilities. Only these 3 of them. So whatever data is being collected has to be given out everywhere in the organization. Lean maintenance is where you try to identify the different types of waste. You try to take in steps to eliminate or reduce the waste. Computer aided maintenance is where you deal with a bulk of data. You need to find out where so you have to find out different methods to use computer systems to arrange this data and analyze in a timely, efficient manner. Okay. computers don't get tired like how human labor do. So you can rely on computers to do your maintenance. Now, what is breakdown? Breakdown is where you have to do some sort of you know what do I say, repair or maintenance work on your machines. All right. So this when the machine stops working, this may be attributed to any mechanical reason or any electrical reason. Whichever be the type of machines, be it mechanical or electrical, you have to find out what is the cause of the breakdown, why has it stopped, and you undertake the repairs work. Okay, this is your general understanding about breakdown. Breakdown is not planned. You don't know whether it is going to break down next hour or whether it's going to break down, whether the machine is going to break down tomorrow. So you cannot plan that breakdown. Okay, that would happen. So there's no way of stopping it, but you can stop it only if you do proper maintenance. So when that thing is not even planned, when a machine breaks down, the production is delayed, it is halted for some time, your workers turn idle, you have to get the repairs and all this. So it leads to a lot of cost for the organization. So it is always better to adopt a very good method of maintenance so that breakdown can be reduced. Otherwise, because it is unplanned, and once it happens, it adds on to a lot of cost. Okay. Now, maintenance breakdown may have one or two causes. It might be a technical, electrical snag, a short circuit, or some voltage issues, or any other causes. So you have to find out what is the main cause. Maybe even maybe proper inspection was not happening for the plant. People were overlooking it or ignoring it. That is why it can have a breakdown thing. So you have to find out the core reason as to why there was a breakdown. So here what it the best way to counter this breakdown is to have a proper maintenance plan. For each machine you have to decide, you have to fix out a plan with the schedules, with the people who are supposed to work when, where, weekly chart, PERT or CPM, whatever be the method, you need to have a proper maintenance system. You need to check when all should the maintenance be done. If inspection is done, someone has to go there and sign it. So you need to have a proper record thing. So if suppose the management asks you, okay, why are how frequent are the breakdowns, you need to have some data to show it to them. All right. Then spare parts. So this can be with relation to your what do I say, um, you know rel the reliability factor, wherein your machine, though it is expected to do some work in a given set of conditions, it is not doing. So maybe you have to change one component, like I gave you an example. So that is where you have to stock up certain spare parts, certain additional things. So suppose the wheels, which is kind of shown in the figure, so maybe, or the screw or whatever be the thing, everything has to be kept with you. And the things which you use to tighten the screws, your spanners or pliers or whatever you call it, all those have to be readily available. It should not, you should not have it somewhere far off. You should have it in the factory premises itself, so that if there's a technical snag, someone can go quickly, get the tools, do it, and set the motion, set the production working smoothly. So all those have to be rightly kept. So an organization should decide whether they have the right number of spare parts. No overstocking, no understocking, because it adds on to the cost. See that everything is available. You stock up the right quantity in the right time, in the right price or right place. Everything including your spare parts has to be maintained. So this is a general rule for all types of inventory. Spare parts inventory is also one classification of inventory. So those have to be readily available and stocked in a proper manner. Okay, you don't have spare parts, you have to wait maybe for 2 or 3 years for spare parts to come from outside, then this causes a delay in your production. You might not be able to land up with enough goods by the end of the day. So your customer level will not be satisfied. As a result of which, in the long term or in the short term, your profits can go pretty down. So here what we need to understand is, machines, the spare parts have to be in the right, you need to have the right amount, the right quantity of spare parts with you at the right price or right place. Then we have to ensure that uh, you know it is closer to the place, closer to the machine, you can easily access those. Okay, if you don't have spare parts, you would find it difficult to meet the production deadlines, then it's going to fall bad on the satisfaction level of the customers. So these are the concepts of maintenance management. We discussed the types of maintenance, how is each type differentiated. We learned about the breakdown aspect, we learned about spares, planning and control, we learned about things like equipment reliability. What is equipment reliability? What are the two types? What is maintenance scheduling? What are the different small techniques of doing maintenance scheduling? We also learned about the different 6 new methods of maintenance, scientific maintenance. So this is what is maintenance management all about. If you didn't follow the explanation somewhere down the line, let me know. All right.